Everyone, this is Umasankar, All India AD Coordinator. Welcome to Sri Chaitanya. Welcome to Season 1 of JEE Max Mains Advanced Extremes Series 2. In Series 2, recently we have completed Series 1 of Season 1 of JEE Max. In Series 2, we are concentrating the concepts, problems, shortcuts, assignments and tests on the topic Ellipse, which is very important in conic section after a parabola. This is about the lesson 2. Actually, in a previous video, we have completed ellipse lesson 1. There, I have shown a beautiful video, and with the help of that video, we are visualizing the real locus and the definition of the ellipse. And through that video, we have learned so many points. Now, today, through this, we are concentrating the analytical approach and the terminology of the ellipse in this lesson. Hope the continuation of the lessons are very important. Of course, in lesson 3, the next concepts of ellipse will be covered. Again, my suggestion would be, please don't forget to check the description. And if you like this video, please share and subscribe and press the bell icon. There you will get the notifications one by one. My friends, now through this video, here I am introducing the basic standard definition and information of the ellipse. See, as I mentioned earlier in our lesson number 1, if SP by PM is equal to E, what is S and what is P and what is PM and SP by PM is equal to E? That here once again I am explaining. Suppose this is the plane and this is a fixed point, let it be P, and this is the fixed line. So this is a fixed point and this is the fixed line. This line you call it as L. This is fixed point is S you say, and this is fixed line L. And this is some variable point P. This is some variable point P. Draw SP and draw a perpendicular PM from P onto the fixed line L. So PM is the perpendicular distance drawn from the variable point P and join the S and P where S is the fixed point. If the ratio, that means the distance ratio SP and PM, that is SP by PM is equal to E, and that E lie between 0 to 1. So if the all values of E lie between 0 to 1, then the locus of P is called the ellipse. And what kind of, if SP by PM is equal to E, what kind of locus that we are getting and that you have visualized in our lesson number 1 through that video. But this is the analytical definition of the ellipse. Here, this number E is a positive number, but it is always lie between 0 and 1. Of course, you know it very well. If E is equal to 1, then the locus of P is nothing but a parabola. If E lies between 0 and 1, then the locus of P is called the ellipse. Here E is called eccentricity. This is called eccentricity. Already these are the familiar terms, and of course, my friends, this lesson is very important. And of course, the standard general equation of the ellipse is x square by a square plus y square by b square is equal to 1. This is the general equation of the ellipse. And here two cases will exist. One is, here x square by a square under y square by b square, if a greater than b, this is one case, and if a less than b, that is another case. What does it mean by? If a greater than b, how can we imagine and what kind of ellipse that we will get it? I am explaining through this diagram. Whenever a greater than b, then the ellipse is like as shown in the figure. That means here the major axis is along x-axis and minor axis is along y-axis. So when a greater than b, here this is the ellipse, this is the closed figure. It intersects x-axis at 2 points, capital A and A dash, and the length of A dash, that is 2 small a, and intersects y-axis at 2 points b, b dash, and the length of b, b dash is small b. And here, if the ellipse intersects x-axis at A and A dash, where C is the center of the ellipse, then here x-axis is called, that A dash is called the major axis and B, B dash is called the minor axis. If A greater than B, then the situation of, or the picture of the ellipse is like this. So this is stretched along x-axis as shown in the diagram. And of course, my friends, here S and S dash are the foci. P is any fixed point, any variable point, not fixed point. And of course, this is a directrix, and this is also the directrix. Everything I will explain each and every term, but see the points one by one. First point. So as shown in the diagram, it is a closed figure, and it is symmetrical about coordinate axis. It is symmetrical about coordinate axis. That means the curve which is above x-axis is equal to the curve which is below x-axis, or the curve which is right to y-axis is same as right to left to y-axis. So it is obviously it is symmetrical about coordinate axis. Here in the diagram, several points are here. Of that, what are those points? If you have observed the diagram very carefully, there you will identify several things of that. A is there, capital A is there, and A dash is there, and B is there, B dash is there, and S is there, S dash is there, and this capital M is there, and M dash is there. What is Z is there, and Z dash is there. Small L is there, and L dash is there, and C is there, and of course capital L and L dash are there, and capital Q and Q dash are there. What are those points? And what are the importance of these particular points one should practice? Okay, one by one, in the next points I will explain what are those things and what are the relations with respect to the ellipse also I will explain it. Now see my friend, this is second point. Here, every chord through C, this is a C, every chord, if you have drawn any chord means if you have joined any 2 points, on the ellipse, that is called chord on the ellipse, chord of the ellipse. But here what I am saying, every chord through C, that means you draw any chord through C. You may draw infinitely many chords. Through C. That C bisects all the chords. So the point which bisects all chords, then that point is called center of the ellipse. Here we represent the center of the ellipse as what? C. That is about the C. That is the definition of center of the ellipse. So the point which divides all chords which passing through that point to the ellipse is called the center of the chord, center of the ellipse. This is the first definition, and the notation for center as a C. Of course, these are all the standard notations. Situationally, we may change the notation. That's a different story. Depends upon the problem, but concept. Try to understand the concept. Now coming to next another point. See, the curve meets x-axis at capital A and A dash, and y-axis at capital B and B dash. So here this capital A and A dash is called the major axis. This is called the major axis. And capital B and B dash, this is called the minor axis. So here major axis is along x-axis and minor axis is along y-axis. This is all for what? When A greater than B. What are A and B? If you have observed the standard equation of the ellipse, x square by A square plus y square by B square is equal to 1. There it is A and this is B. So here A dash is called major axis and B dash is called the minor axis. And if A greater than B, major axis is along x-axis, not x-axis is the major axis, it is along x-axis, and the segment A dash is called the length of the major axis, and the segment B dash is called the length of the minor axis, and minor axis is along what? Y-axis only. Okay, and my friends, now next, since the ellipse intersects x-axis at A and A dash, So these A and A dash are called extremities of the major axis, and these extremities are also called vertices of the ellipse. So if anybody is asking you about what are the vertices of the ellipse, immediately you are in a position to say that where the ellipse meets x-axis, where the ellipse meets x-axis. This is the general ellipse I am talking. Here in this general ellipse, my center of the ellipse as C. If I have considered that as origin and major axis along x-axis and minor axis is along y-axis, if I have considered that, if you imagine that, then coordinates of C becomes what? 0, 0 only. So for this ellipse, if ellipse intersects the x-axis at A and A dash, therefore A and A dash are called the extremities of the major axis and also called the vertices of the ellipse. This is all for what? A greater than B case. Okay, the same points, just imagine for A less than B case also. That means everything you have to imagine along y-axis, that is the only case. So through this video, I am just concentrating A greater than B. I am giving that A less than B or B greater than A case as homework for you. You just practice all these things and imagine, and if possible, draw the necessary diagrams also for that. Now coming to the fifth point. Yeah, this is very, very important point. Sum of the distances SP and S dash P is equal to 2a, 2 small a, not to 2 capital A. Sum of the distances SP and S dash P. Since S is called focus, and here two focus are there, so in plural we can call it as foci. So sum of the distances of the foci from a point is a constant. That concept, how can we visualize that I have explained in our lesson 1 through a beautiful video. There you will understand the position and the locus of the point, how it moves. And if you are tracing the location, or if you are identifying the track of the point, then automatically that locus itself indicates what? Ellipse. That's why this is the most important definition for the ellipse. So whenever sum of SP and S dash P is a constant, which is 2a, then sum of the focal, these are SP, the distance between focus and any point on the ellipse, that is called focal distance or focal radii. I can call it as focal distance. I can call it as focal distance or focal radii. Please try to understand the definition well. Both are same. Don't get any confusion. So here what I am writing, sum of the focal radii or focal distance of the ellipse is equal to length of the major axis. What is 2a? Length of the major axis. That means distance between A and A dash is called the length of the major axis. Okay, if sum of the focal distances is equal to length of the major axis, then we can say that the locus of P is ellipse. The statement itself is also a bit several times, even in advanced examination also, they asked questions exclusively on this particular area. And how to visualize this, that I have explained in our lesson number 1 video. So the locus of the point which moves such that sum of its distances from two fixed points is constant. It is called, then the locus is called ellipse, and those two fixed points are called what? Foci. That's why the two fixed points are called what? Foci. So for A greater than B, for closed figure ellipse, there exist two focus and we can call it as foci. So how many foci will exist? Two foci will exist. Okay, yes, they usually or in general we represented with the notations as S and S dash. Or sometimes if you read the statement properly, they may change the notation. That's a different story. In general, in standard books, always foci represented with S and S dash only. This is the most important definition on an entire ellipse. This is about the fifth point. Now coming to my friends, again a sixth point. The chord which passes through the focus. See, imagine, observe what is the card and the card which passes through the focus. You just imagine how many cards are there and what type of cards are passing through the focus. You just observe the diagram, and it is perpendicular to major axis is called the lattice rectum. See, there exist so many cards passing through focus. The card which passing through the focus is called the focal card. The card which passing through the focus is called the focal card. If S is focus, then there exist infinitely many focal cards to the ellipse. Of that, there exists a card or there exists a focal card which is not only passing through the focus but perpendicular to what major axis. Then that focal cord, length of that focal cord is called the lattice rectum. That is called what? Lattice rectum. So all lattice rectums are focal cords, but all focal cords need not be the lattice rectum. That is the relation between what? Focal cord and lattice rectum. So from the figure, capital L dash is called the lattice rectum. The same thing we can also expect here also. Here also. This is also the lattice rectum. Or through this focus also you can imagine infinitely many number of focal cords. I am least bothered about all other focal cords. But the cord which is passing through focus and perpendicular to the major axis is called what? My lattice rectum, and its length is called length of the lattice rectum. So whenever they are using the word lattice rectum, that doesn't mean that length of the lattice rectum only. And the lattice rectum is always what? Perpendicular to axis of the ellipse, which is x-axis, or parallel to y-axis, or it is parallel to the minor axis, I can say, and perpendicular to the major axis, I say. These are all are what? For A greater than B case only. These are all are what? For A greater than B case only. Now coming to 7th point, the midpoint of the midpoint of vertices. That means already I told what are A and A dash and what they called vertices. And here the midpoint of A and A dash is also called center. And the midpoint of Z and Z dash is also called center. There are two definitions for center. One is midpoint of A and A dash. So that means CA is equal to CA dash. So this distance is equal to this distance. And CZ dash is equal to CZ. And what are Z and Z dash? If you have drawn a foot of the perpendicular from a center onto the directrix, this is what? Directrix. So how many directrices are formed for an ellipse? Two directrices will appear. That's why this is one directrix cell and this is another directrix cell. If you have drawn the foot of the perpendicular from center of the ellipse to the directrix, that is Z, then similarly center of the ellipse to another directrix, which is foot of the perpendicular, that is Z dash, then the midpoint of Z and Z dash, that is center. So CZ is equal to CZ dash. Similarly, CA equal to CA dash. These are all are the very, very, very important notations one should practice. These are all the important derivations, definitions, fundamental things one should remember. Nowadays in mains examination, just they are concentrating on these particular areas only. You collect all the problems related to this particular information. Even for board examinations also, they are very, very important. Now, my friends, coming to the 8th point. Here, see, now you understood what are A and A dash and what are B and B dash, what is center and what are the foci, and what are Z and Z dash, and what are the directrices L and L dash, and what is lattice rectum and what is the focal cord. Slowly we have learned several things. But here, the another important point is, here, this point A, this is one vertex. This point A divides the segment SZ. This point A divides the segment SZ in the ratio E is to 1 internally. This point A divides the segment SZ. SZ means S is focus and Z is foot of the perpendicular from focus onto the directrix, or foot of the perpendicular from center onto the directrix, whatever it may be. Always A, the vertex, divides the line segment joining S and Z in the ratio E is to 1 internally, and A dash divides SZ E is to 1 externally. This is also the costliest point we may expect very good questions based on this particular information. So please practice questions based on this particular 8th point. Okay, my friends. Now coming to 9th point. If the ordinates of A and A dash are equal, if the ordinates of A and A dash are equal, then major axis is always what? Parallel to x-axis. Or if abscissae are equal, then major axis is parallel to y-axis. See, this is all about what I am talking about. X square by A square plus y square by B square is equal to 1, my friends, where A greater than B. So you just imagine, suppose if A less than B, then the situation may be like this. You just imagine. So this is center C, and this is my x-axis, and this is my y-axis, and my ellipse is like this. And there, this is my S, and this is my S dash. These two are the foci. There, this is my B, and this is my B dash. Now these are becomes the vertices. Now, of course, here it is directrix. One directrix and another directrix. This is L and L dash, and this is about Z, and this is about Z dash. Same thing, same thing. And of course, this is any point P. This is SP and S dash P. This is about SP by PM is equal to E, or sum of the focal distance SP and S dash P is equal to 2B. There, that is 2B. SP plus S dash P equal to 2B. What is length of the major axis? Here, major axis is nothing but what? Along y-axis. So you just imagine all the things for what? A less than B or B greater than A. Both are same. So in that aspect only here I am showing. And moreover, this is about what? This is called the ellipse x square by A square plus y square by B square equal to 1, where A less than B. So whenever we are talking about ellipse, okay, whether it is A greater than B case or A less than B case. If it is A greater than B, immediately imagine the major axis is along x-axis and draw the convenient figure. And immediately you identify what are the vertices, what are the foci, and what are the directrices, and what are the length of the lattice rectangle, everything. Similarly, if A less than B, immediately you can say that, okay, major axis is along y-axis, then automatically change the figure and conveniently you imagine all the things. And of course, these are all are what? Major axis is along x-axis and major axis is along y-axis, respectively, under the cases A greater than B and A less than B. And moreover, my center has origin. Moreover, my center has origin. Suppose you just imagine the ellipse x minus h whole square by A square plus y minus k whole square by B square equal to 1. You just imagine. If you just, and here A greater than B case, you just compare this with x square by A square plus y square by B square is equal to 1. What is the difference that you have observed from these two equations? In the place of x, it is x minus h. In the place of y, it is y minus k. That means, if x square by A square and y square by B square is equal to 1, then this is the ellipse at which center has origin and major axis as x-axis along. But in this case, the center is what? At h comma k. The center is what? Along h comma k. That means if you have shifted the origin to the point h comma k and imagine an ellipse where the major axis is parallel to x-axis, then the situation should be like this. This is my old x-axis and y-axis, and these are my new x-axis and y-axis. Just imagine. So that is the beauty of transformation of axis and rotation of axis. That's why in our junior inter, we have learned and practiced and studied the concept of transformation of axis. Here what I did, I have parallelly shifted, I have shifted the origin. So the same thing. So whenever I am talking about vertices, yeah, you know the original vertices. So there in the vertices, you have to equate the x coordinate to x minus h. Thereby you will find x. And you have to equate y coordinate to y minus h. There you will find the y coordinates. For what? Where the major axis is parallel to x axis. This is all about what? For A greater than B. You just imagine the graph, imagine the curve which is situated if A greater than B and major axis is parallel to x axis. These are the beautiful, simple points. And similarly, the same thing may holds good even for A less than B, that is along y-axis. In general, in competitive examination, they should ask questions on this particular areas only. That's why please don't underestimate that part. Now, my friends, now coming to 10th point. Here, the distance between the foci. Here already I introduced what are S and S dash. So, the distance between S and S dash, that is 2AE. Whenever the distance between S and S dash are 2AE, then automatically the coordinates of S becomes what? AE comma 0, and the coordinates of S dash becomes what? Minus AE comma 0. Therefore, coordinates of foci plus or minus AE comma 0. These are the coordinates of foci. For what? For ellipse x square by a square plus y square by b square is equal to 1, where a greater than b. Similarly, for ellipse x square by a square plus y square by b square is equal to 1 for a less than b, the same thing you can write it as 0 comma plus or minus b. We are changing the order of the coordinates, and moreover, in the place of a, we are writing b. And moreover, the distance between z and z dash is equal to 2a by e. 2a by e. That means the distance, whenever the distance between z and z dash is 2a by e and c is the midpoint. So, this equation of the directrix is x is equal to a by e. This is the equation of this directrix. And the equation of this directrix is x is equal to minus a by e. Therefore, what are the equations of the directrices? X is equal to plus or minus a by e. And coordinates of z and z dash are z is a by e comma 0, z dash is what? Minus a by e comma 0. So with the help of these two particular information, we can imagine what are the coordinates of z and z dash. I will give all that information at a glance in the form of a tabular form also. Just here I am explaining. Okay, my friends. Now coming to the 11th point. Yeah, directrices. Here, try to understand directrices of the ellipse always perpendicular to its major axis. This is one of the standard point, and of course you can imagine the questions, very beautiful questions based on this information. Directrices, what are the directrices? This is about directrix all, these are the directrices. This is one directrix and this is another directrix. Directrices are always what? Perpendicular to the major axis. These are always perpendicular to major axis. Okay, now my friends, see this table. Yeah, through this table, actually as I mentioned above, coordinates of the center for this ellipse 0 0, and for this ellipse this one. Suppose if this is the ellipse x minus h whole square by a square plus y minus b whole square by b square is equal to 1, where a greater than b case, then for center what to do? You equate x minus h to 0 and y minus k to 0, then that becomes x comma y, that are becomes h comma k. So now h comma k are what? Center, coordinates of the center for what? X minus h whole square by a square plus y minus b whole square by b square, k whole square by b square is equal to 1 for a greater than b case. And this is where the major axis is parallel to x axis. And of course for a greater than b, the vertices are plus or minus a comma 0. Here you have to equate x minus h is equal to plus or minus a and y minus k is equal to 0. Therefore, x is equal to h plus or minus ae and y equal to k. Therefore, h plus or minus ae comma k. These are all are what? Vertices of this ellipse. What is this ellipse? Whose axis is parallel. Similarly, foci. For this ellipse, foci are plus or minus ae comma 0, and for this ellipse, x minus h whole square by a square plus y minus b whole square by b square equal to 1, you equate that x minus h to plus or minus ae, therefore foci becomes h plus or minus ae comma k. Similarly, length of the lattice rectum is 2a, here also length of the lattice rectum is 2a, no change at all. And length of the major axis is 2b, here also length of the major axis is 2b, there is no change at all. Here, equation of the major axis is along y-axis, that is y equal to 0, there y minus k equal to 0. And equation of the minor axis is along y-axis, that is x is equal to 0, there x minus h is equal to 0. These are all are what? For a greater than b case. The opposite version comes under A less than B, and the same thing will holds good even for the ellipse whose major axis is parallel to y-axis. And coming to this table, and of course, my friends, for A greater than B, this is the relation to find eccentricity. B square is equal to A square into 1 minus A square. This is the formula for identifying or finding ellipse eccentricity. And for A less than B, this is the formula. Even the two formulae are holds good even for this ellipse whose axis is parallel to x-axis or whose parallel is parallel to y-axis. That means for A greater than B or A less than B cases also, the same formula will holds good. And for this ellipse, for A greater than B, equations of the directrices are x is equal to plus or minus A by E. For this ellipse, x minus h is equal to plus or minus A by E. Therefore, x is equal to h plus or minus A by E. This is what this is equations of the directrices for x minus h whole square by A square plus y minus b whole square, y minus k whole square by B square equal to 1, where A greater than B case. Similarly, the same thing holds good for the next case also. And of course, length of the lattice rectum 2b square by A. Even for this ellipse also 2b square by A. For A less than B, it is 2a square by B. And similarly, focal distance, that is SP. This is A plus or minus Ex. There you will get H plus A plus or minus Ex. Here Y plus K plus B plus or minus Ey. So what, my friends? These are the basic definitions and information one should practice. Really in examinations, especially in mains, even in advanced examinations also, they are asking the questions based on all these facts. If you are good at these formulas, sometimes you need to practice, you need to by heart these formulae. At least these are essential. Okay, so in this lesson 2, here I have given all the basic fundamentals of the ellipse and the standard notations and information and standard formula of the ellipse. Hope if you like this video, you please share and subscribe my channel, and you please press the bell icon. There you will get the notification. And please, again I am telling, don't forget to check the description. And we will meet with lesson number 3 of the ellipses soon.